Hello friends, welcome back to our training session about sensitive ground fault detection methods. Till 4 we have discussed around 10 videos, 10 sessions about the sensitive ground fault and about 3I0 stage with cosine of phi and sine of phi. This is phi we have discussed. And 6 sessions about the directional transient ground fault. Right now we are going to discuss about the 3I0 stage, greater stage, 3I0 greater stage with the angle, with measuring angle of V0 and 3I0. If you want to have better knowledge about sensitive ground fault detection, please refer to the previous videos, previous sessions, and watch all of them till you can have then very high knowledge about the settings and the knowledge beyond the settings. And kindly subscribe our channel in YouTube and help us provide you better clips and better free information settings about the relays and the protection. So let's start discussing about the 3I0 greater stage with angle between V0 and 3I0. Here we are. What I have said that we have already we had around 2 sessions and 1 introduction part. Total 3 sessions about this part of the functionality for the sensitive ground fault detection methods, and we had 8 sessions about the ground fault detection with measuring cosine and sine of phi, and 6th session we had about the transient ground fault detection. Right now we are discussing this guy, that is the ground fault detection by 3-0 greater stage with phi of V and I. Let's go through the logic diagram and the block diagram, functionality diagram of this part. This is the function diagram for 3I0 greater stage with measuring angle between voltage and current. Of course, the angle between zero sequence voltage and zero sequence current. In this functional diagram, first we take the V0 and 3I0 compensated value. What is this the 3I0 compensated value? This is what we discussed in the first sessions of sensitive ground fault detection methods, that we have some angle error compensation by these parameters. Then we have 3I0 compensated value. We have V0, a 3I0 compensated value, and these two values are supplied for the direction determination block. And after this direction determination block, when it goes to the block number 1, another goes for the comparison with the set direction, that this set direction should be forward, non-directional, or in reverse. We have 3 methods and 3 ways to select forward, trip, or trip as a non-directional, to be non-directional, or in reverse direction. Then that signal goes to AND block. This AND block is from the threshold values. If it passed the threshold values, here are the threshold of zero sequence voltage and threshold of zero sequence current. And now it is supplied to the pickup. Another part of the pickup is going to block number 2. This is block number 1 and number 2, that is going to fault not in a trip area. If here we have signal the block number 2 is reversed now. If we don't have any signal from this AND gate, then if we have a signal from block number 1, it means from the direction determination. The direction determination block works and we have an output. But here we don't have output. It means it is defined for the relay that it is not on a trip area. We are giving just oral information about the working of this functional diagram, but each one of these blocks we will discuss furthermore step by step. We'll discuss about the rotation angle of reference voltage, about direction determination delay, the minimum zero sequence voltage for direction determination, and zero sequence current threshold for passing to have a pickup. And here we have two signals. One is inverted from the voltage, and another is from the output of and after threshold of passing of 2. These are after passing of the thresholds and delay of the zero sequence current and zero sequence voltage. This is inverted, so if we don't have any signal from after threshold, if we don't have any signal, we have 0. If we have here a 0 signal after passing of the current threshold, it means that the current is not past the threshold. And here also we have 0. The output of this block becomes 0. And we don't have a set signal to trigger the Q output of to determine that the ground fault method is phi 3 I0 greater with the phi of V0 and I0. But here the output, we know that here the output is 0 from the voltage threshold. We do not pass the threshold. But now it is inverted, so 1 is supplied to the reset terminal of this SR latch, to the R terminal. And this R terminals triggers the Q bar, or we can say Q dash. That is the stabilized against the intermittent ground fault, and here a ground fault detection method. And the output from here to determine that we have a ground fault and detected with the method of 3I0 with phi of V0 and I0, this becomes 0. So this value is not shown. Another part of the block is related to block with inrush current detection. This inrush current, and this is the selectivity whether it should block or not. The output, if it goes to this AND gate, and block the delay and operation. It blocks the operation if this one goes to operate, but if we select that we should block the operation, this will block, and our operation and fault recording will be blocked. We will have this pickup, but it will not operate because we have chosen to block the operation. It's just an introductory part in part 1, in session 1. It is just an introduction. So in the second session, we will discuss more about the rotation angle of zero sequence voltage and direction determination delay and why we select this. If we had time, we'll go for the minimum thresholds. And second session. Please subscribe our channel for providing you free courses about the control systems and the protection of power system.